lucky for you, I'm not going to talk at all about complex systems and how to manage forests as complex systems, but I will rattle through a bunch of really basic silvicultural stuff. I'm going to kind of confirm what Chuck just told you, with maybe a little more detail and a little more specific context. I think it's really, forestry is contextual. It's, you know, space, place matters. And when dealing with these mountain pine beetle issues and thinking about all the stuff we've talked about in the last day or so, context matters. And I think it's really, really important to keep that in mind when thinking about what to do with these damaged stands. So to restore or walk away, in many cases I like to think of it more as how quickly should you run away? Because, you know, there are cases where I think that's the absolute best thing to do. Just turn around and run. Don't deal with that stand. All right. So first off, a few numbers. You know, in British Columbia, you know, among other things, we're very proud of being able to throw out really big numbers about mountain pine beetle. So the operable land base in British Columbia is about 22 million hectares, you know, the stuff that we log. And that includes all of our coastal forests. So, you know, it's but of that 22 million hectares, about 10 million hectares has been, you know, impacted by the mountain pine beetle in some way. Of that 10 million hectares, about 5 million hectares is actually pine dominated, so more than 50% pine by volume or basal area or whatever. And we've had a very aggressive salvage logging strategy for you know, 10 years now. And through that salvage logging strategy, which is aimed at that 5 million hectares of pine-dominated forest mostly, we've managed to log a little over 1 million hectares salvage logging. So there's about 4 million, maybe, you know, maybe there'd be a bit more salvage logging. So let's say there's 3.5 million hectares of pine-leading damaged stands unsalvaged within our operable land base. So, you know, that's a lot. And what happens to this remaining 3.5, 4 million hectares, I think, is probably the most significant forest inventory and growth and yield projection challenge that BC has ever faced. It's huge, and we really don't have a good understanding yet of what's going to happen to these unsalvaged stands. You know, the ones that we've salvaged and planted, you know, we've got a pretty good handle on what will happen to them. Within these unsalvaged stands, and that's all I'm going to talk about today, is recovery in unsalvaged stands. I'm not going to talk at all about clear cuts or recovery after harvesting. So basically, you know, we need to know something about the speed of recovery. We need to know something about the growth rates of the surviving trees. And we need to have an understanding of what will happen in terms of post-disturbance regeneration, natural regeneration. The composition of that regeneration and the abundance of it, and the speed at which it occurs after the disturbance. And so those are primarily that's the stuff I'm going to talk about, is what I've learned about with those issues in the last few years. I kind of got first involved with mountain pine beetle issues by trying to get a better understanding of how many non-pine trees are actually in a pine-leading stand, which was another thing we really didn't know much of anything about at the time the epidemic came along. So that's how I got into it, because, you know, thinking about, you know, should we harvest these stands to begin with, right? Then I moved along and I did work on regeneration, and the most recent stuff I'm doing is the growth rates of the surviving trees, the recovery, and how do you project that into the future. So let's start with regeneration. You know, regeneration is kind of a good logical place to start. So stalking after a disturbance, there really is only two mechanisms that we have to concern ourselves with. You're either going to have an existing seedling sapling bank that survives the disturbance and provides stalking for the site, or you're going to get some sort of pulse of new post-disturbance recruitment. And really that's it. I mean, there's not, it has to be one of those two things. We're very familiar with a pulse of recruitment after fire. you know, after a major fire, we often get a really nice pulse of recruitment, especially in lodgepole pine stands. But that's not necessarily the case in these mountain pine beetle stands because the disturbance is different. So let's rattle through those two things. So what is the situation with existing seedlings and saplings in the understory? Well, back to the 4 million hectares, somewhere, you know, 500,000 to 750,000 hectares of that 4 million is very poorly stocked. There's not much of anything there. Maybe he looks a bit like this or worse. So, you know, then you have to rely on the pulse of regeneration to take care of those. There's 2 to 3 million hectares that are kind of marginally stocked. You know, then maybe they're okay, maybe they're not. The other thing about the stocking is that it's very patchy and spatially heterogeneous. So if you put in a plot, you might get some decent stocking in one plot, and then your next plot has nothing. So there's, you know, you have to be concerned about the spatial patterning of the stocking as well. And often the average, the mean, doesn't really tell you what's going on. You need to have an understanding of the variability in your stocking. And obviously all that sort of stuff has yield implications. So that's the basic numbers that we found in British Columbia, that, I don't know, whatever that is, 20% of your damaged stands are really poorly stocked. 50% of them are iffy, and another 20 or 30% are probably in really good shape. Now, I don't know if that's the same here, if the same situation of your stands. I suspect it might be similar. You know, we've got similar sort of ecosystems. And so that's something you want to be aware of and think about. Advanced regeneration. This was, I think we were in this stand maybe 10 years after the mountain pine beetle hit. And these are spruce trees. And they were all just maybe 50 centimeters tall at the time of the beetle. And they've released, and they're growing really well. And there's I don't know if you can see it, there's a little naturally regenerated pine right there, which is kind of cool and unusual. And there's all the moss that Vic was mentioning, which is an evil thing when it comes to natural regeneration. I'll get to that. So anyhow, you know, you can have some nice trees in the understory, and obviously if you had an abundant number of these spruce trees in the understory, you'd be quite happy. And apparently in Colorado, you don't need very many at all. To be totally happy. I was trying to do the translation. I thought maybe it's acres or hectares, or I'd forgotten how to convert, or that was a really no number, Chuck. Anyhow, minimums. We all know that managing the minimums has its issues. So we move on. Another just picture of, you know, fairly good stocking in a lodgepole pine dominated stand, and out of my mouth might slip the word secondary structure. It's a term we've coined in British Columbia to refer to pretty much anything that survives the epidemic. In old school forestry, that would just be residual trees. But you know, you need new jargon. So if I do say secondary structure in this talk, I'm referring to anything that has survived the disturbance. So natural regeneration. What's natural regeneration post-beetle? I'm still on that. So how do you predict it? How do you get some sense of what's going to happen? Well, really, I think it's a function of three things. You have to know something about your seedbed substrates. You have to know something about the canopy condition, and you have to know whether or not you have any a seed source. And so parent tree proximity and abundance. Like if you've got lots of live trees, and they're big and they're close, then you know you're more likely to get natural regeneration. So those are the kind of the three factors that you need to have some understanding of, and they will in turn affect your probability of natural regeneration and success. And so we'll go through a bit of that. Seed source. This is, you know, that proportion of the stands that aren't doing so well. This is brutal, right? I mean, we have whatever it is, you know, somewhat less than 1 million hectares of stuff that looks like this. So here, it's kind of the extreme, right? I mean, you've got no seed source. If the whole forest floor under here happens to be moss, you're toast, right? I mean, you're you're not going to get regeneration. You don't have a seed source, you've got a lousy substrate, you might as well try to restore it or rehab it. So that's kind of straightforward and easy to deal with, right? I mean, those are the ones you might go to. Of course, if this one is too far from the mill, you've got a problem. If there's no road to it and all those sorts of things. So then what do you do with it? Even if it's still in your operable land base, maybe you do weird things like you got described yesterday. I'm still thinking about that one. Onwards. So seedbed substrate. The moss is really a big issue in our forests. The moss forest floor pretty much impedes natural regeneration, and not much happens for 5 or 10 years. If you're on in our ecosystems, if you're on a drier site type where you have either lichens or needle litter or something like that on the forest floor, and I think in Colorado that's the case. There's more needle litter and just straight dirt if you kick with your shoe. Whereas in our forests, you have to make your way through a moss layer before you find anything. But anyhow, on sites with needle litter and lichens, you will get pretty reasonable natural regeneration of pine fairly quickly in our ecosystems. But on these moss, where there's, and this one isn't the best picture of moss, but where there's a lot of moss, no, you have to wait for the canopy to break up, sunshine to get in, the sun to kind of sun scald the moss, and then the seed bed becomes more receptive and you start to get regeneration. So let me just show you a bit of data on that. This is from a study where we looked at the current epidemic in British Columbia. So we went in, we kind of aged the age of attack. So we looked in stands, but weren't attacked. Then 1 year old and 2 year old and 3 year old. And when we did the study, about the oldest stand we could find was 9 years after attack. The main thing to notice is that there's a lot of zeros for the first 3 to 5 years, and then you begin to get a bit of regeneration of subalpine fir and spruce, and you get very little pine until later on, and that's the whole breakup thing of the moss. So the main thing to get out of this is that not much goes on for the first few years, and my opinion is that that's totally driven by the substrate. In this particular study that we did, we started at a seed source. We started at a nice subalpine fir, spruce, bunch of trees, and then we went at a right angle into a pine-dominated stand with very little other seed source. So anyhow, not much happens in the first few years. That's what I want to get from that. The regeneration of pine and spruce. We tested all sorts of different models about the stuff I just mentioned, seed source abundance, proximity, size, blah, blah. But when it came to kind of shade-tolerant species, especially pine, really what it was a combination of the substrate and shade. So if you had fairly high basal area, and this is both live and dead trees, so it's kind of still shady, then pine just wouldn't regenerate there. But it didn't like the seed bed; it was too dark. And even if it did regenerate, it was too dark, and they died. Similar thing with spruce. They a little more okay for shade, but still basically until the canopy breaks up between the substrate and it being dark under there, it's a tough place for regen. Subalpine fir, the most shade-tolerant species, really just regenerated as a function of the parent tree abundance. So as the local subalpine fir overstory basal area increased, the abundance of regeneration increased. And sorry about the numbers over here, 50 meters squared and 0.2 and everything else. You just multiply that by 200 and you get to per hectare. So that's 0.2 times 0.1 times 200 would be 20 stems per hectare. I should have changed the axis, especially for the Americans. Let us move on to a different place. So that was a description of a study with that we did in the current epidemic in British Columbia, and we went in, just a few years after the epidemic happened. This is a study that we did down in the Flathead, and the Flathead is in the very southeastern corner of British Columbia and right against the border of the U.S. The Flathead had just a wonderful epidemic, really, between 1976 and 1981, and basically in 79-80, all sorts of trees were killed. It was kind of the height of the attack. And then in 1980, I guess it was the summer of a winter of 80, 81. I don't know if this is true or not, but apparently it went down to -50. And, it actually held at -40 for a week or two or something. And, just stopped the epidemic cold. Just, boom, over. So from a retrospective perspective, a tremendously interesting place to go and study. And when we went down there and had to look at the stands, you could just, there were dead trees still on the ground, and you could see little beetle galleries in all the trees, and there were no, very little mortality post-beetle. There was just recovery of the trees that survived the beetle epidemic. There were no kind of standing snags or anything you could find. It's a tremendous place to study retrospectively. Way easier to deal with trying to understand mountain pine beetle than going into the current epidemic. Anyhow, so we went there and we took about 22 stands. We tried to get a gradient of mortality from fairly low mortality to high mortality. We put in 5 plots per stand, and we took everything apart. We did destructive sampling. We reconstructed what happened. You can really understand what's going on when you take chainsaws into these stands and take them apart. What did we find? Let's go back. I'm still on regeneration. The bars on the left was the amount of regeneration pre-beetle, right, just when the beetle hit. So, and this is regeneration is trees less than 1.3 meters tall. So you can see that there was, it wasn't a particularly well-stocked place. There's maybe 100 to 200 stems per hectare pre-beetle. And the bars on the right are the number of trees less than 1.3 meters tall in about 25 years after the beetle epidemic. And you can see that they are stocked to I'll say that was 2000. They're stacked to a pretty good level. The stocking is, 1,000 to whatever, 8,000 stems per hectare. So 25 years after the epidemic, in this particular Flathead area, there's lots of regeneration, and it's a nice mixture of species. So how did it get there? Again, because we did all this destructive sampling, we were able to sort this out. So this graph, one of these little bars is the amount of recruitment of trees less than 1.3 meters tall in a 5-year period. So this is the recruitment that occurred over time in these flathead stands. By the way, the flathead stands had a massive fire right around here somewhere, and they were larch and Douglas fir stands, and there'd been fires before. I don't totally understand the history of the place, but this is the recruitment of understory trees after those big fires, and but the recruitment here pre-beetle doesn't include any of the overstory pine trees, right? It's the understory trees that recruited, but non-pine trees that recruited in. Does that make sense? So and then this is the amount that occurs in 5 years. So the beetle was around here, and you got a little, recruitment increased, but the main thing to get out of this graph is that there was a big pulse of recruitment 10 to 20 years post-beetle is when the majority of recruitment came in, and then it crashed right back down to low levels like it was pre-beetle. So I'll go back to this moss. I think it's the moss, the evil moss. And it takes 10 years for the stand to open up, for the sunlight to get in, for the moss forest floor to break down, and then you get this pulse of recruitment, and then the trees that have survived in the stand, they start to close over as well after 25, 30 years, and the moss forest floor redevelops, and you get right back to the kind of the pre-beetle condition. So I think this is a reasonable model for what you should expect for natural regeneration in northern forests that have moss-dominated forest floors. And that's also what Anne McIntosh has pretty much found here, I think, in that herbicide-killed experiment. So I think I've beaten that to death. We'll summarize it. Regeneration in MPB disturbed stands can be sparse and patchy up to 10 years post-disturbance. Seedbed substrate still dominated by moss, and moss is a lousy substrate. Shade-tolerant species were limited by overstory shading, and expect a pulse of regeneration 10 to 20 years post-disturbance, and the stocking levels may be pretty good after this time. So you have to just decide whether or not you want to be patient, really. So let's move on to the trees that survive, the so-called secondary structure, the bigger trees. So back to the flathead, and like Chuck, I've got my growth increase core, except I have the advantage of the 1975 penny, which I thought was pretty good to come out of my pocket in a place where the beetle attack was 1976, 1979, whatever it was. And that was just, random luck. That was pre-poor Jim Flaherty and his getting rid of the penny. Anyhow, I felt really bad about Mr. Flaherty. It's not fair to pass away right after you retire. So anyhow, this were the trees in the flathead, and growing very slowly, an understory tree, and then excellent release. And we cored all sorts of trees when we were figuring out this site, and we counted them up. And in just about all cases, the release got us to within 2 or 3 years within when the epidemic actually occurred. And it seemed that release took maybe 2 or 3 years after the epidemic. And then you got very good release of most of the trees.